Section 6.1 18-T. In the following probability distribution, the random variable x represents the number of activities a parent of a K to 5th grade student is involved in. We want to complete parts A through F below. First things we want to do is verify that this is a discrete probability distribution. If we look at the probabilities, they are all in between 0 and 1. And then we want to find out what is the sum of all the probabilities. So if we take 0.462 plus 0.074 plus 0.246 plus 0.069 plus 0.149, we get the value of 1. So this is a discrete probability distribution because we can see that the sum of the probabilities is 1, and each probability is between 0 and 1 exclusive. Now what we want to do is we want to be able to graph the discrete probability distribution. So we can open this up into StatCrunch. So if we open this up in StatCrunch, okay, so if we want to graph this, we're going to go to Stat, and then we're going to go to Calculators, and I'm going to scroll all the way down to where it says Custom. Okay, and then the values in are going to be the X, and the weights in are going to be P of X. So let's go ahead and hit Compute, and now we can see what the graph looks like. So therefore, here we have our graph. So again, in the graph, we know that the horizontal axis is the values of the discrete random variable. And we can see that the vertical axis is the probability. So this is the probability. And we can see that the horizontal is going to be the number of activities a parent of a K to 5th grade student is involved in. Now what we want to do is we want to be able to compute and interpret the mean of the random variable x, and we want to compute the standard deviation of the random variable x. Now we can do this by hand, which we've done already, but there's another way to be able to do this by using technology. So we've already kind of figured that out by looking at the graph. So let's take a look at the graph. Well, if you look at the graph, it already gives you the mean here, and the mean is 1.369. So we can say that the mean of the random variable is going to equal 1.369, and that represents activities. Okay? So this means that as the number of experiments increases, then the mean of the observation will approach the mean of the random variable. Okay, and then we want to compute the standard deviation of the random variable x, and again we're going to use the graph here, and if you look here, there is the standard deviation. So we're going to round that to 1 decimal place. So you can see it says 1.479. So what we're going to do is we're going to say that the standard deviation is going to equal 1.5, and that's 1.5 activities. So now in part E, it's asking us what is the probability that a randomly selected student has a parent involved in 3 activities. So what that means is a student with a parent involved in 3 activities, that corresponds to when x is equal to 3. So what is the probability of when x is 3 on our table? Well, if we go back up here, we can see that when the value of x is 3, then the probability is 0.069. So therefore, it's 0.069. So we would say that the probability that a randomly selected student has a parent involved in 3 activities is 0.069. The next question says, what is the probability that a randomly selected student has a parent involved in 3 or 4 activities? So this states that a student with a parent involved in 3 or 4 activities corresponds to when x is equal to 3 or x is equal to 4. Okay, so what we're going to have to do is we have to add the values for the probability of 3 and the probability of 4. So we know that the probability of 3 is equal to 0.069. And then let's go back up and then find out what is the probability of 4. So if we come back up here, okay, we know that for when x is equal to 4, the probability of 4 is 0.149. So we know that P of 4 is 0.149. So now we need to add these together. So when we add them together, we get the probability to be 0.218.